I wish there was one button I could press that would just make that all happen all at the same time. But there just isn't.
One of these days.
Did we not bring Nicole back? Okay, never mind. We're just going to roll. She's got some kind of office move thing happening. Hey, everyone. My name is Fraser Cain. I'm the publisher of Universe Today, and this is your weekly Space Hangout for Friday, December 20th, 2013. The last episode before Christmas. So I guess that's important.
Oh, is it Christmas?
Yeah.
I wasn't quite sure.
Has that not been beating down on you from all media channels at all times? So this week we are going to be talking about adorable Japanese space robots, emergency spacewalks, Morpheus flights, simulated Mars mission, landing on the moon, the opposite of the supermoon, which we are going to get to the bottom of today, the Gaia launch, Apollo 8, and the Earthrise photo, the cool stuff you're going to be able to see in 2014, Starless cloud cores, and that is everything. So, joining me this week, we've got Amy Shira Teitel.
Hello.
Who has been raging about Apollo, what, 7 all week? 7.
Yeah.
Not the one we're going to be talking about today.
No. Hope you guys aren't sick of Apollo yet.
David Dickinson.
Hey.
What is your...
Today, Bolivia launched their very first satellite, and they're now part of the Space Club. They launched it on a Chinese rocket named Tupac Katari, is the name of the satellite. It's actually named after one of the founding fathers of Bolivia.
That's awesome. All right.
Yes. So, and they had a massive party. It was kind of wild to watch the launch. It was kind of cool.
How come you didn't put that into the list of stories?
This just came off a few hours ago. I just came from watching it online, and I didn't even know they were going to broadcast the launch live until one of the engineers told me about 20 minutes prior or so.
We would be all over that story. All right. Jason Major.
Oh ho! Happy Christmas.
You are clearly the festivist of the bunch. And we got Nicole Gugliucci.
New office!
And a TARDIS. Is
And
that
a
how you
TARDIS.
get to and from home?
Yes, that is my extra storage space, actually, because we have so much CosmoQuest swag here, and NASA swag.
Is it?
No, I wish I really had a TARDIS for that.
It's just like a big piece of cardboard up against your
it is.
wall?
Yeah,
Okay.
yeah. The Blog S wrote about it, and I had to buy it after I saw that.
That's really cool. Elizabeth is going to be joining. Elizabeth Howell's going to be joining us, but she's like talking to an astronaut or something right now. So
Whatever.
Likely excuse.
Whatever.
like, yeah. Hold on, guys. I got to talk to an astronaut. So, okay. So let's talk about. I would say the big news that just happened, really just like was yesterday, right? Was the launch of Gaia, which is so
Yes.
great. So,
Yes.
Jason, give people the background on what Gaia is.
So yesterday Gaia launched, like Fraser said, and it was an early morning launch. I have to admit I didn't watch it live. It was like 4 o'clock in the morning my time. I was still snuggled cozily in bed. So, but it launched from ESA's spaceport down in French Guiana, and I want to say it was like 9:12 Universal time. And it was a beautiful launch. I mean, there were clouds moving over in the pre-dawn sky. The Soyuz rocket lit up those clouds beautifully as it kind of like the exhaust was peeking in and out from behind the clouds. It was really, really amazing. Go check it out on Universe Today.
I'm gonna show the video in a second here.
Okay, fantastic. Anyway, Gaia is Europe's mission to map the Milky Way, and that sounds like a very lofty goal, and it really is. I mean, it's an incredible mission to observe and plot the locations of 1 billion stars in our galaxy. And
1% of the entire galaxy.
a full 1%. So I mean that's just an amazing feat. And what Gaia is going to do is it's going to orbit a Lagrange point, which is the Sun-Earth L2, and that's 1.5 million kilometers in back of the Earth as seen from the Sun. So it's kind of I use the term in my article in Earth's shadow, and some people said, well, it's technically not in the shadow because it's not being hit by Earth's umbra. That is true. It will not experience any Earth eclipses of the sun, but it is in that location directly away from the sun as seen from Earth, or I'm sorry, directly away from Earth as seen from the sun. It will orbit this point for 5 years using 2 cameras observing this ginormous field of view. And over those 5 years, it will observe all billion of those stars 70 times. Mathematically, that comes out to 40 million observations every day. The goal is to create a complete 3D map of our galaxy. This has never been done before. It is going to let us know more about the Milky Way than any other mission before that. And in addition to plotting the locations of stars and the brightness of stars, and I made a little cheat sheet here because Gaia is actually doing quite a lot. It's going to find exoplanets around nearby stars. It's going to identify brown dwarfs in locations where they haven't yet been found, namely the local area of the galaxy and orbiting nearby stars. It's going to look for asteroids both in the main belt and beyond, and possibly even Kuiper belt objects and minor planets that we weren't aware of but previously. It's going to look for supernovas, possibly 100,000 supernovas over the course of that 5-year mission. And it is going to look to identify gravitational waves that were predicted by Einstein. So Gaia is going to be a really, really busy mission. There's going to be a lot of incredible science coming out of it, possibly for the next half century. They're going to be using Gaia science and findings to just let us know everything about everything.
That'll be wild if Gaia detects gravity waves before LIGO does, because Ad LIGO comes online, I think, next year. So
Nicole, I don't know if you're an expert on this, but isn't this sort of like one of the last predictions made by Einstein that still hasn't been confirmed definitively yet? Is just these?
I want to say yes, but I'm not sure if I know enough to make that comment. That's a Matthew Francis question.
It sure is, yeah.
I visited LIGO before, and they know gravity waves. They exist. They just haven't had the direct detection yet from LIGO. But within the next couple of years, they will.
Yeah, they've detected them around pulsars, like pulsars that are orbiting each other, and black hole.
Co-orbiting white dwarfs.
Right, and so that you get the gravity waves happening there, but I don't think they've seen. Yeah, they haven't detected a gravity wave pass through the Earth. So anyway, but I mean, can you just imagine? Imagine when they've actually made that first map, and then they plot out the positions of all of these stars. I'm sure Google or someone's going to come along and make some kind of cool 3D thing that you can explore. Just like go to this star and go to that star, and
this is kind of a follow-on from the Hipparcos mission that did astrometry a few years ago too. So this is and it's going to be interesting. Like Jason was saying, there's going to be new comets, new asteroids discovered. There's a class of asteroids I had never heard of when I was writing about this called Apophis asteroids that orbit within the inside of the Earth's orbit. They're aphelion is inside our orbit that they may be able to discover with this. So it's in another space telescope. James Webb is going to be going to the L2 in a few years as well. So
now take this into consideration too. Gaia is going up there with this whole suite of cameras. In effect, Gaia is a 1 billion pixel camera that's going to be looking out into the galaxy from 930,000 miles away. I mean, there's nothing has been to that level of resolution looking into our galaxy like this. So anyway, Gaia launched yesterday, and I think it's gonna take about a month for it to reach that L2 point, but everything's going very well so far.
Yeah.
Oh, there were some amateurs that caught images of it last night on its way out.
On its way out?
L2 point, yes. ESA had a website that they put up that has animations. Looks like a little star moving, like a satellite moving against the background, but there were some amateurs that caught it last night.
But was it doing like some kind of like an orbital burn to try and get to that higher orbit?
I don't know if they've done the burns yet or if they're going direct there, but it's definitely, they said it was about a 10th magnitude star, so you would have needed like a telescope to see it. It's not one you'd see with your naked eye. So
And it would be hard to know whether it was just a satellite or whether it was actually the
You'd have to
spacecraft.
have the ultimate positioning system, so you're aimed right at that location and be able to track it for an hour or two. Yeah.
Wow.
Right. Go Gaia.
Go Gaia! Yeah,
Yeah.
no, it's really exciting. This is one of the missions that I've been super excited about, and you're going to hear me go on and on about this all next year. But the Rosetta one, where they harpoon a comet, that's next. That's the next big one that I'm
That's
excited
August.
about.
That's August, right?
Well, I think it does the I think it's in November is when
I
they
think
do the harpooning.
they just reactivated Rosetta this week, I believe. They woke it up from its slumber. It launched in what, 2003, 2004?
I know. I've been following. I've reported this. When Universe Today was just me, I was reporting on this story and the launch and the early stages of the mission. They went past like some asteroids, I think, and took some pictures. So anyway, no, really exciting. Okay, let's move on to the next story. Now I want to talk about Apollo 8. Now, Apollo 8 already happened, Amy, I think.
Well, yeah, everything I do has already happened.
That's not news.
That's not news.
Well, the news is that this year it happened 45 years ago, so people are going to be talking about it. I mean, this is sort of like the classic Christmas story, space nerd edition. Slash for Jews who didn't grow up with Christmas. So Apollo 8 launched on December 21st and in 1968, and on December 24th they went into orbit around the moon, and they were in lunar orbit for 20 hours. They did 10 revolutions, fired the main SPS Service Propulsion System engine to begin their trip back to the Earth on Christmas Day. The famous quote from, I think it was Jim Lovell, they did the burn on the far side of the moon, and NASA was sort of waiting to hear back. The time of their reacquisition of signal would be the indication of whether or not the burn had been successful and whether they were back. And they said back, "Be advised, Houston, there is a Santa Claus." So, when you don't have Christmas growing up, that's a good Christmas story. But what's sort of significant about this, and yes, as we mentioned slightly earlier, that I'm sort of stuck in the early Apollo missions right now, is that this was the first mission that did more firsts than I think you can count on both your hands. Like first crew on a Saturn V, first crew to leave the Earth's sphere of influence, first crew to go into orbit around another body, first time a engine left lunar orbit, first time something went into lunar orbit and successfully left it, and it was really that sort of big thing that, aside from Apollo 11 or Apollo 7 sort of proving everything worked, actually did it. Like, this is the first time the spacecraft did what it was designed to do, which was to fly to the moon with people at the controls. And Fraser just showed it, but you should show it again because I was talking through it. NASA has recreated the famous Earthrise picture, and this is I think every single edition of a Best Pictures of the 20th Century book has this picture in the center on the cover. It's that Earthrise. I do a screen share, but I don't know how to do it right without crashing my computer. It looks like this. Is there sound to it that we can hear?
I couldn't.
No. Yeah, so it was this is what they saw. This crew became the first to actually see the Earth from the moon, and it's you always hear astronauts say that we went to the moon to discover the Earth, and it was really this picture that sort of like sums up, this is our tiny little planet, and you can't see anything beyond our little oasis in this terrifying desert of space. Yeah, so
first human beings to set eyes on the far side.
Set eyes on the far side of the moon.
Yeah. Right?
Yeah. First time anyone actually saw, I mean, there had been grainy pictures, but the first people to actually see the entire disk of the Earth, actually get that far away. I mean, they'd had sort of, 850-mile orbits before, but nothing that showed you that. So
I always felt in some ways, Amy, that Apollo 8 was the most exciting of all the moon missions, even more than the landing. Of course, I was only 6 months. I was only 6 months old at the time, but so.
Yeah, I really think that aside from Apollo 8 and Apollo 13, it's probably the most recognized mission because it was this really, really bold step for NASA to do, which you don't see that kind of guts anymore. Like, there was a lot that could have gone wrong, and they knew that this is the only way to make up time after sort of, the Apollo 1 fire and having just take such a huge step back. And just sort of like, no, we're just going to do it. Like, we don't have a lunar module, let's just do it.
Now the great part about that video is you get the we get the feeling that we're inside the capsule with the astronauts. I mean, you're listening to them, you know, kind of talk amongst themselves. They're saying, "Hey, give me the color film. Hey, look at that. Oh man, I missed it. Oh, I have it over here in this window. You know, calm down, Lovell." I love that one. You know, I mean, that was great. You know, I mean, they're really trying to catch this shot because they see this amazing photo op, and really, I mean, it's kind of like it's there and gone because Frank Borman is rotating the capsule. So eventually, you know, they're going to lose that view. Actually, they would have seen that view earlier, except that it wasn't through their window. So they didn't even know there was an Earthrise. You know, it was kind of like in back of the capsule.
Yeah, well, this is the thing that people don't really realize is that the moon is tidally locked to the Earth, and so if you're standing on the surface of the moon, the Earth will hang motionless in the sky at all times. Now it's gonna wobble around a bit in the sky because of the libration of the moon, and there are places that you could go on the moon where you would see this kind of Earth rise a bit, like right on the edge of the moon. You would see the Earth rise and then go back down and back and forth as the moon is librating. But for most people, you know, they would never see that unless you're in orbit around the moon.
Yeah.
You're just not going to see this sight, and so that's part of what's exciting. Is it's kind of not only is it rare for humans to go around the moon and see this kind of a thing, but in fact, even if you're on the moon, you would never see this. You would never experience the Earth rising in this way. So it's it's just a phenomenal sort of piece of work. It's great. I mean, I think they really captured it, and it's great that NASA has kind of gone back every year. I mean, it really is something they like to come back every year and re-celebrate, and good on them. I mean, what a picture.
Yeah, there aren't many that sort of parallel that. So.
And thanks to you know, LRO for being up there and mapping the locations, because it was because of LRO that they were able to tell where Apollo 8 was was at that point in time and recreate the whole thing. So, you know,
it's amazing when you think about it, right? They're able to simulate the exact craters that they were going over and that exact point of view of the Earth and match it all up. And just amazing. Okay, great. Let's move on. So, Nicole, some kind of starless cloud core. What's this about?
Yes. Why do we care about clouds that don't have stars in them? We actually learn about star formation from them, which is pretty cool. I'm going to screen share. I'm on my work computer, so it won't crash, I hope.
Yeah, it looks great. I think it's all working just fine.
So this is an image that was released from the ALMA, the Atacama Large Millimeter Array, which of course you all know and love as the new telescope interferometer being built in Chile. And this fuzzy, orangey, mishmash cloud here is what's known as a starless core. It's a very dense molecular cloud somewhere in the Milky Way that doesn't have any signs of star formation in it. And what's important about this? So as we've talked about before, star formation is something we know a little about, but we don't know quite how it happens. We have a pretty good idea of how gas can collapse and form stars about the size of our sun and smaller, and that's most of the stars in the Milky Way. But the more interesting stars are those really massive stars, things that tend to go supernova. They're 8 solar masses or more at the time of when they're on the main sequence during most of their lifetime. But we still can't quite figure out how these stars form because in all of our simulations, things start to break up and break apart until when they're the size of, you know, medium-sized stars or small stars like the sun, medium-sized star. So how do these large stars form? There's got to be some mechanism that's propping it up. And the way to look for that mechanism is to find these clouds that don't have stars in them before it started to collapse. These are really hard to see because, of course, they don't have stars shining light out of them. So you need a millimeter wave telescope to get to that light. And so this was a great image and a paper that came out in Astrophysical Journal. I will share the link to the press release in a minute. Where they actually imaged this cloud, looked at how much deuterium was in the cloud, because deuterium can only exist in a really cold environment where there's no stars yet. So they measured the amount of deuterium, and they speculate that it's the magnetic field that's keeping the gas from completely collapsing into smaller stars, and also the fact that it's a large cloud to start with. So this is the nature-nurture argument. Because it starts in a larger cloud, it has a better chance, they think, of creating larger stars. So that is the new cool image coming out of ALMA in Chile.
And you've been to Alma, right?
I have. I got to go for the inauguration. That was back in March. March now, yeah. So really amazing site. We had little oxygen bottles because up at the high site, because it's well above. It's one of the driest places on Earth and well above much of the Earth's atmosphere. So enough that I'm like a sea level person. That it was a bit of a struggle, and I was really excited and jumping up and down and taking pictures, and that probably didn't help.
And how big is the facility? I mean, just how big is the Alma? I mean, is it?
It'll end up being 66 antennas. As far as I don't remember what.
And when you say antenna, you're talking like big old radio dish, right?
Yeah, although it's kind of small and cute, and when you compare it to some others, but it's really, really, really high precision. 12-meter, mostly 12-meter, and some 7-meter radio dishes. Yeah. Right now they're going to be in their compact configuration, but they'll also be able to move the antennas on these amazing trucks, which I got to see roll by. They move them out on these trucks to larger configurations, so you get better angular resolution.
Now, Nicole, is that something that the square kilometer array would be able to get better looks at when that's all set up?
So the square kilometer array, as it's being built, I don't know much about its millimeter wave or sub-millimeter wave capability. I know they're talking a lot about the low frequency and the mid-frequency. I don't know if they're going ahead with the high-frequency part of it. I hear more and more about the mid-frequency and the low-frequency.
So then clouds like this would be what, not visible at those frequencies?
Right. You're not going to see. Yeah, you're not going to see it unless it's a millimeter wave telescope. And so Alma's still got a good couple of decades of really productive science ahead of it before they have to worry about building the next big millimeter wave telescope.
They just resolved the workers' strike down there too this year, didn't they?
They did. Yes. I don't know how long that was. That was for a few weeks, I think.
Yeah, I remember reading about that.
There was a worker strike, and it's an interesting conundrum because the workers wanted more pay being in such a hazardous site, and the organization that manages the telescope was kind of stuck because relying on federal funding means the money isn't necessarily there to give them the higher. They did end up resolving it, but it wasn't a pretty situation. It wasn't a pretty situation, but it's all working again, and I think they're working on. There's another proposal cycle going on right now, so astronomers are madly writing their proposals to get time. It's probably oversubscribed by a factor of 10 at least, and it's still not even officially all the antennas in place yet.
David, there's a supermoon. No, wait, the opposite of a supermoon happening.
That's no supermoon.
That's no supermoon.
No, we just had, this past Monday, we had the smallest full moon of 2013, and it's kind of unusual that during the next lunation, we're going to have the smallest full moon of 2014. They're going to be literally back-to-back. And I actually did a little bit of research when I saw that. I wonder how rare or uncommon are they paired together in December and January like that. And it turns out the last pairing of mini-moons like that we had was 2004-2005. And the next pairing we're going to have is 2021-2022. So about once every decade or so, this kind of phenomenon comes around. I always have to tell people it's not. I always have to say the apparently visually smallest full moon, because the moon is not physically getting larger or smaller. It's just moving away. The moon, through apogee and perigee, varies through its orbit. And when it occurs during a full moon, we have a supermoon or a mini-moon. The mini-moon is a little is a little less known term. It kind of has a PR problem. It doesn't have the big reach that supermoon does. And whenever I write a supermoon post, usually you get the supermoon haters and the supermoon likers out there, because a lot of people argue that supermoon is not anything really. The moon reaches perigee and apogee every orbit. It doesn't always do it near full or new. So it's not really anything that unusual.
Because it's like it's kind of a double-sided there.
Yeah.
It gets people interested in it who wouldn't normally even really think about the full moon unless they're driving home from work and they go, oh wow, check out that moon.
I say it reels them in for a discussion on something that's real fact-based science. So I'm kind of okay with it. And this one actually was very near the solstice too, so that's kind of interesting. It doesn't really. This last full moon was the long night's moon during December that stays high above the horizon all night. for Northern Hemisphere viewers. This is the winter solstice for the Northern Hemisphere, and the summer solstice, I like to think of it as the southward solstice. That way we don't leave anybody out. So the Southern Hemisphere viewers don't say, well, it's not winter down here, you know, so you don't have that argument. I like to think of them as the northward June solstice and the southward December solstice. So
I hope that all of our Australian viewers have a wonderful, warm, hot Christmas. The way the way it's normal.
I've been down to Australia before. They go to the beach for Christmas. So
yeah. Like you should. That sounds like that sounds very civilized to me. Well, joining us is Elizabeth Howell. Hey, Elizabeth.
Hey, how's it going?
Good. Now I know you had a busy phone call that you had to take, so now you're back, and so we've saved up all of your stories, and so now
that's really kind.
Yeah, we're gonna hit you with them. But I think the big story, and a bunch of us can talk about this as well, is just the update on the Chang'e landing, Chang'e 3.
Yes,
so where are they at now?
Well, I actually don't have the extreme latest on that, but I know that when they landed, that everything went just as planned. And I don't know if you guys saw that spectacular footage on television that just was played of it coming down and lowering itself to the surface and then actually driving away. And from what I can see, everything has just been going swimmingly. Now, it is going to be hitting a period of blackness in a sort of sense because it's going to be so hot on the lunar surface that they won't be able to operate it normally. So just for the sake of electronics and such, they're going to actually be closing it down for the next couple of weeks just to make sure that it's all safe, and then resume those operations. And the rover should be moving for about 3 months, they say, at planned, although who knows, it could go a lot longer. And the lander's supposed to be there for about a year.
Let me see if I can get some video here.
It was just amazing to watch that live. I was getting goosebumps.
This coming week, they should experience their first sunset for the Sinus Iridium where they landed, so that'll be interesting. I know they have nuclear generators on it to keep it running for the 2 weeks while it's in darkness, but.
And what's really exciting, of course, is all that high-resolution video and other pictures that are going to be coming from the surface. And the interesting thing, too, is they also have an agreement with the International Lunar Observatory. I'm not sure I have that acronym right, but essentially they're a client of Moon Express. And what that group wants to do is to get some telescope images from a small telescope that the Chinese are going to be putting onto the surface of the Moon. And then the idea is it's an MOU, sort of an agreement. And then when Moon Express actually sends its own missions there, which it's hoping to do in 2015 and 2017, then the Chinese would have access to that data. This is astronomical data, to be sure. It's not engineering data.
Come on, YouTube.
Very cool.
I broke YouTube. Hold on, give me a second.
I think it was the Apollo 17 astronauts deployed a UV scope on the moon, but it was only for the brief time they were there. This one's going to last for a while.
Yeah, exactly. And I would have to go and take a look at the specs, but I would think they'd probably be a little bit more advanced, right? Just given that it's been
an ad
years later.
Elizabeth, now, what's the scope trained on? Is it going to be remote operated, or is it going to be aimed at a certain portion of the sky, or?
I don't know what portion of the sky it's going to be trained on. They haven't been giving a lot of information on that. I do know that the rover itself is going to be trying to look at ancient lava flows while running around there. So it should be interesting to see. I'm just related about the science on this because it has been about 40 or so years since we've landed on there, and just think of all the advances we've had in technology since that time.
Elizabeth, I know that Laddie was going to do some measurements. Has there been any word from that mission as far as like the dust that Chang'e had stirred up or anything?
That looked like kind of a hard landing a bit, didn't it? Look at that! Look at it go!
I think Elizabeth's frozen.
Yeah, she's frozen. Yeah, that was one of the things they talked about because there was some original worry that it would disturb Laddie's observations of an undisturbed moon, but that turns out not to be the case. They're pretty excited about being able to do those observations.
Yeah, that's kind of cool. They're going to get some other science out of it.
Mm-hmm.
It's very Spirit and Opportunity-esque, isn't it?
At the end of the day, it's a pretty small spacecraft that's landing on there. I don't think that it would have a global impact, all the dust, although I'm sure it would move away.
It's going to have some impact, yeah.
I look forward to the copyright takedown request I'm going to get for posting that video. Yeah, the YouTube copyright policy is overly evil.
Are you going to get a cease and desist?
I am yeah, I will. Well, but they're using the Chinese feed, right? So
Google has robots now. Just know that.
No, I know. They don't just have robots. They have that terrifying.
It's that thing from the Matrix. It just There's a squid flying outside.
Yeah, no. They got the cheetah bot, right?
Yeah.
The one that'll go, what is it, 20 miles an hour, and just run you down. And then
You
they've got
just
this.
get in a car and drive away from it.
Have you guys? Oh, I gotta find
Yes,
this.
I've written about those actually.
Have you? Do you remember what's the company called?
It's Boston Dynamics.
Boston Dynamics.
Okay. All right. I'm gonna find this, and we can watch this horrendous
that,
vision of the future.
that horsey thing in the woods totally freaks me out. I mean,
yeah.
Oh,
if I
there's
were, they want.
Here we go.
I did a listicle.
I
for
wish
a
I could
site
provide you with
on
the
those.
sound, because it
We're gonna get
sounds
a
like
notice for this
a
too now.
lawnmower.
So glad this is not my channel.
This is it. You know what? I'm just gonna go with a scorched earth policy now. I'm just gonna let
What
them.
is this?
Like, who knows? I think we lost track.
It's called the Wildcat.
Oh, that thing, yeah.
Yeah.
Oh, yeah.
But you can't hear it. Is the thing.
I want to ride
It sounds like a chainsaw.
It sounds like a chainsaw. So imagine it's like some guy on a little motorbike, like a tiny little putt-putt off-road bike.
That would be an interesting lunar.
Oh,
rover
it
right
gallops.
Holy moly.
It
Yeah.
looks like it would trip on things, though.
And it moves like
It would need to
serious.
get a little bit more height.
it moves like something out of a Tim Burton nightmare. I mean, it is just like or
Like
or-
a- It's
You
like
mean
a
Tim Burton
dog-
adorable movie?
yeah.
The thing is, the movie that there just shows the thing walking along, and you're thinking, okay, I can handle this, and then it goes into full gallop, and you're going, oh my gosh, I'm in trouble.
Yeah.
So,
Skynet's here, basically. So.
Yeah. But hold on. Let's see if this is the part where they kick it. I think this is the one where they kick it. Hold on. Oh no! It's
Ooh.
all right.
Wow.
Yeah.
I, for one, welcome our four-legged masters.
It can bound. Sure can. Yeah. Corners.
Wait till they wrap a horrible skin around that thing. Oh.
Look at that. Oh. Yeah. So
And
this
we
happened.
are-
So the reason we're showing this video, by the way, is because Google acquired Boston Dynamics this week.
Yeah.
And Google is the people who we're doing this Hangout with, and so this should all be kosher. I look forward to my takedown request. All right.
Back to space. We have a comment from Flores Brent saying the last few meters they dropped Chang'e freefall to prevent some extra dust from flying around. So that
Right.
was
You don't want to
according
get that
Flores
stuff
Brent.
in. Right.
What the heck are you showing? Could you?
I'm leaving my screen share on. There we go. Okay.
Thank you, Flores. I apologize.
All right. Let's
No,
move
actually,
on.
I don't. Oh,
But you have
Tom
something.
Nate says we need to add the coconut clopping for the sound of the calibration.
Yeah, I got to hear it. I got to hear this chainsaw rolling in my ears. You guys didn't. So. All right, let's go back to the actual news of the day. Elizabeth, emergency spacewalks.
yes, that's actually something I've been following pretty closely the last week, as well as probably a lot of other space reporters, because it's been pretty neat. So what happened essentially was last week on Wednesday, the space station had an automatic shutdown of its cooling system just because one of its pumps was malfunctioning. There was a little valve inside of it that was giving them trouble, and so NASA decided to take two paths just to try and figure out what to do next. So the first path was, okay, let's try and get a spacewalk together, and the second path was, okay, let's see if we can actually fix this valve from the ground. And so while they were getting the spacewalks done on one side, they were doing all these procedures on the other to see if they could move the valve in some way, or maybe there was a backup valve, there's another valve they were looking at a bit further upstream that they could try and fix. So anyway, they were playing with all of this, and then the interesting thing happened, which is the space station is actually going to be going into an area called high beta, and that happens every year around this time, around December 30th. And what happens is you have so much sunlight hitting the station that it becomes difficult to do dockings and to get spacecraft up there and to do spacewalks. And so just because NASA was hitting that period, they thought, you know what, it's probably a better idea just to get the spacewalk done before they enter that period and they run out of other options. And so that's what they're working on right now. They have 2 astronauts that are going to be heading outside on Saturday, on Monday, and possibly on Christmas on Wednesday. And these 2 guys will be out there trying to disconnect the pump, fly up to get another pump that's sort of sitting outside of the station, bring it back over to where the first pump was, reinstall it. Then they're actually going to stow the failed pump outside because they think that in the future they could actually get another valve installed inside of it and to get it working again if necessary. They want to repurpose the parts, right? It's just expensive to bring stuff up there, so as much as they can repurpose stuff, the better. So that's what we're going to be watching and just making sure that people are going to be safe out there. Now, the big thing about this actually is that it'll be the very first spacewalk since that big leak back in July. I don't know if you guys remember that, but Luca Parmitano, who's an Italian astronaut, was outside. He was wearing a NASA spacesuit, and then all of a sudden, all this water started coming into his helmet. And so NASA, of course, got him right back to the airlock as fast as they could, and then they spent weeks and weeks and weeks going through the spacesuit trying to figure out what's been going wrong. And so they're still looking at the root cause. They do have some ideas about what happened, and they swapped out some equipment and they put it back in to try and sort of put some new stuff in to just try and get it recalibrated. But in the meantime, they've added 2 key procedures for astronauts to be following while they're out there. The first one is to do what's called a HAP check, it's basically, I forgot the acronym, but it's basically sort of like a sponge that's going to be sitting at the back of their heads and making sure that if any water does come in, it's going to be going into there, so if they feel it starting to soak up, they're going to realize that there's a problem and they can go and tell mission control and they're going to take things from there. The other thing that they've done too is they put a bit of tubing inside there like a snorkel, and that will just give them a backup place to breathe if they do happen to get a lot of water around their face. The snorkel does go to another part of their suit that does get some oxygen. So as long as those 2 things work in as well as they're supposed to, then they do have some backup procedures if the worst decides to happen again.
Now, I've heard that the astronauts have a little piece of Velcro in their inside their helmet they can scratch their nose with, too.
Yes, exactly, because you can't scratch your nose out there, obviously. If you open up your visor, you're in big trouble.
Yeah, exactly. Oh, it would be worth it, I think.
So we got a question early on about asking from Stuart Rosenberg, asking why are spacewalks considered so dangerous? They've been doing them for decades. And I think you already gave one great example of how it's still dangerous.
Drowning in space.
Drowning unexpectedly. But maybe you can comment further on how dangerous they are after all these decades.
Well, when you think about it, you're going outside, you're in a little mini spacesuit of your own, and that's really your last line of protection against any kind of problem that's out there. So a few of the things that could be holding you up are, say, if you're walking along the station and your spacesuit happens to snag on a piece of metal or something, then you might get into a problem where you have some air leaking from there. You also have issues from radiation, you have issues from meeting solar radiation, the heat that's coming over, you have issues from micrometeorites possibly hitting you, and it also is just really, really hard to do it. It's a lot of hard work. It looks easy because they've been practicing it a lot, but apparently it's just a real exertion out there. And so there's also the concern about astronaut exhaustion. So there are a number of concerns that go into it, and it's really something that in this situation they were looking at. I don't quite want to say as a last resort, but they wanted to see if there was something that was less of a risk to people beforehand before getting out there.
I mean, it's important to think about they have to take all of the components of a spaceship and miniaturize them down and make it available to an astronaut. And so you need all of the things. You need pressurization, you need heating, cooling, radiation shielding, and all the things you have to carry around on your body. And so there's less room for having redundant components, and if things go, if your cooling system shuts off.
And they're in there for a long time. I mean, they're out working for 8 hours.
About 6 hours, 8 hours, yeah.
Yeah, it's a 3-diaper spacewalk.
Of solar heating, speaking of solar heating...
That's not where we wanted to go with that.
They're doing
I don't think that's how diapers work.
Did I derail you? I apologize.
It's all right. They're doing these spacewalks during right around the solstice where the ISS is reaching a period of full illumination too, so solar heating is definitely going to be an issue for these spacewalks.
Elizabeth, you're going to Mars.
Yeah, not really Mars, but as close to Mars as I can get it. I'm going to be heading down to the Mars Desert Research Station in Utah, and that's a facility that's run by the Mars Society to, as you just said, try and get as close to Mars exploration as possible. And so the crew that I'm going to be part of is led by the University of North Dakota. I also happen to be a part-time student there as taking a PhD. And what we're going to be doing is a series of experiments just to try and characterize a few things about the area. For example, we have one fellow that's going to be heading outside and taking a look for any hydrothermal vents in the region, sort of any signs of it. And then the idea would be that if we can find it in an area that's sort of in the desert, shaped by wind, shaped by dryness, it might be similar to what you would find in parts of Mars. We also have an experiment that's going to be looking at solar radiation, and it's going to be serving as a bit of an early warning system so that if the sun does belch out a flare, we're going to get a little bit of an alert. I'm not quite sure how it works engineering-wise. I'll have to look at it when I get there. But essentially, it will be sending back an alert to us, and we'll be able to tell if there's a solar flare on the way. Now, on Earth, that's usually not a big deal, but Mars does not have the radiation shielding that we do here because its magnetic field is not quite as strong as ours. In fact, it's just a fraction of it. And so if we were able to build it here on Earth, the idea is that on Mars it would also be useful. So we're really looking forward to it. We've got 6 people coming, 4 from the U.S., 1 from Canada, which is me, and another fellow from the U.S. who's a full medical doctor, which actually is pretty awesome in a remote environment.
Ray Sanders says that I should submit diaper to NASA as the standard unit of measurement for spacewalks. Which we should. Now they've done this for many years. I mean, this is like they've been doing this for almost 10 years now. I'm trying to think how long they've been doing these.
Yeah, 2002. And the thing is, the habitat has been going through a lot of changes over those years. You know, for example, for a while they actually had a compost toilet, and you had to do this procedure when you went to the bathroom where you would use a jar, and then you would be pouring it into a funnel, and it would somehow go into the toilet. I don't know. Anyway, not any of that today, thankfully. I'm going to be using a standard flush toilet, and hopefully nothing interesting should happen there. And they also have been doing things like making sure that things are upgraded, because just like the International Space Station, as things age, you need to make sure that they get replaced or modified in some way. So, for example, about 4 years ago, they put in a better kitchen because the other one apparently was just not standing up anymore. And they've been doing things like adding rugs and other sorts of important things. And another exciting thing, too, is they did put a tunnel in between the habitat and a nearby greenhouse. And so it turns out that if we want to leave this 1,200 square foot habitat about the size of an apartment, if it becomes too much for us to be together all at the same time, we can just escape through this tunnel over to the greenhouse and spend some time alone over there. So it's really nice. And they're hoping to add some more tunnels as time goes on.
Well, I think the whole concept is fantastic because it's one of these situations where there's so many tiny little things that they need to figure out. Like, does a spork work in a Mars colony? Like, all of the kinds of little things, as you said, where are you going to go to the bathroom? What kinds of sleeping arrangements? What kind of food is going to work? What lasts? How do you prepare it? How do you protect yourself from radiation? I mean, there's so many tiny little minutia that here on Earth, if there's a problem, you just go down to Walmart and buy the replacement. But when you're on Mars, you can't get any more supplies. So to just test out every single possible, just go through the process. Try to live on Mars. Try to live on Mars again. Do it again. Keep going until we think we've ironed out a lot of these problems. So exactly. I think it's great.
It's a process really of trying to grab all of these data points over time, and it does take years, and just try and figure out what works from an engineering perspective, also what works from a personnel perspective. You have 6 people crammed in there, and you're going to be learning a lot about human psychology in a short time, in that kind of situation, so you've got that. And then you also just got to make sure that your procedures are right, that the geology that you're doing outside, for example, is going to be working on Mars, because we're going to be actually donning spacesuits, if you can believe it, every time we go outside and trying to run all of our stuff out there. So we're going to be learning how to work in a spacesuit and how to collect experiments and how to pick up rocks, stuff like that. So it really is interesting because we're going to be just one small part of a large set of data that's being funneled into the Mars Society. That way when the time comes, they do have all this information available that they can give to NASA or whoever else is interested in heading in that direction.
Would you go to Mars if you could?
Yes, but not the one-way trip.
Not the one-way trip? No.
Not the one-way trip,
the return trip. A show of hands. Who would sign up for a Mars mission? David? Only David.
I would.
Yeah? Would you?
Am I coming back?
Are you coming back? Yeah, no, you get to come back.
If I get to come back, then yeah.
Mars.
You're on the surface of Mars and you get to come back.
Yeah.
Yeah? All right.
I'm not going with is it Dutch or Danish TV company?
Yeah.
Us older folks would die of radiation or natural causes before radiation exposure.
Yeah, there's like an additional 5% exposure of radiation, like cancer risk for doing a year-long mission. Don't worry about it. You'll be fine.
But just old age would get me first, so.
No way. No way. You'd be traveling fast, time dilation. You come back and it would be millions of years into the future. Yeah, you come back millions of years.
Planet of the Apes.
Yeah, exactly. It'd be like,
because Nicole's got that TARDIS in the background, so I mean she can help you out.
Yeah.
No problem.
Okay, so I'm going to share a picture here, and this is the picture that Nancy fired my way, and it's the supermoon and the mini-moon.
Oh, cool. Very
That's
cool.
it. So you know what? MiniMoon. That's it. I'm calling it MiniMoon.
MiniMoon.
Yeah, me too.
I considered Bizarro Moon, but then I thought, wouldn't the Bizarro Moon be like shaped like a cube? I think from the old Superman comic.
Yeah, well, and also, you know, Bizarro, that's a DC copyright. Then
we
comes
would, yeah,
the
we did
takedown
the
requests. Yeah, exactly. So
Now, if
MiniMoon,
somebody-
it has a movie reference, you know, I think.
Yeah, it does.
But
Kind of.
but I think it's good. So I need you all to vow that from here on out, you will refer to the smallest full moon of the year as the MiniMoon. Do you all promise?
I will hereby refer to.
All right.
every
Everyone
article.
watching, this is it. This is how we start a meme. Okay.
Somebody get a wiki up.
Apparently, this is a Sailor Moon character.
MiniMoon?
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 Perfect.
Maybe?
Really?
I don't... Sailor MiniMoon? I don't
Put a
know.
little, put a little skirt on it.
No, the Japanese.
Put the big
things.
long
Threw it
pigtail.
in Twitter, and this is what and Google, and this is what I got.
Yeah? Well, perfect. Then it's not.
Mike-
no one's
Mike
playing.
Press
Clone.
So.
Usagi Small Lady Serenity. What?
All right. Well, we will drive this forward as
Yes,
a thing.
Sailor
so
Chibi Moon. Okay,
done.
there you go.
The MiniMoon. We will report on it every year. We'll see how it works. Okay, cool. Well, I think you had posted the Morpheus flights, Elizabeth. You were mentioning that. We've just got a few more minutes, so do you want to just quickly mention that?
Yeah, I'll just mention that real quick. So NASA has this test bed essentially to make sure that they can know a lot about landing vertically and taking off vertically, because that's something that's useful not only here on Earth but also on other planets, of course. And so they have something that's called the Morpheus lander, and gradually over the last few months it's been rather exciting because we've seen it going from just a small flight to a bigger flight and then take the tether off and actually do a free flight. And in the past week, they've actually done 2 of these flights, and both of them have gone, at least from a preliminary sense, very, very successfully. The last flight that they just had a couple of days ago actually landed within 3.5 inches of its target, from what I heard. So they're quite excited. They'll have to take a look at the data just to make sure that engineering-wise everything worked out perfectly, but you know, it sounds like the team is very excited so far.
Awesome. Cool. Okay, well, why don't we wrap this up so you can go off and enjoy your holiday. Before we do, though, I want to find out interesting things that are going to be happening. Amy, Shira, Teitel, what's coming up?
More stuff on Apollo 7 and Apollo 8 from me. Yeah, one of my things, if you feel like reliving or living for the first time some bits and pieces of Apollo 8, I've decided for funsies just to live tweet some of the most important mission events and put it up with good pictures and anything that I've sort of dug out, because I've been spending so much time in various Apollo online archives lately. So I'll be doing that on Twitter for entertainment for myself over Christmas.
When does it start? No, this is amazing. When does this start?
I think it's 4:53 in the morning Eastern time tomorrow
Oh,
is
interesting.
crew
That's cool.
ingress.
And how long will this go on for?
Till the 27th. I'm not doing every single thing because I have to see my family or my mother will kill me, but major mission events and anything that sort of has any good footage that's available on YouTube, or like really great pictures and stuff, just as a way to sort of make it fun again, because it's such a good mission and this seemed like a fun way to do it. So find me on Twitter and I'll be doing that for the next 6
I think you're onto something. I think that's, because we didn't have Twitter back in the day when these missions were happening, and so this is the way we currently experience these missions.
Yeah.
I think you've cracked the code, Amy.
Yes.
So we're gonna promote
That's very cool.
Apollo
That's
and
really
Twitter
awesome.
missed
I will
each other
retweet
by
quickly.
what, 2 years, I think.
just
Yeah,
a half century or so.
yeah. That would be great to just sort of experience all
Yeah.
of the minutia of the mission. I think that's great. That's a terrific idea.
That makes
And
it
speaking of terrific ideas, David Dickinson, you've got an epic post
Yes,
that's going to be coming.
I have been hiding away writing my 101 astronomy events happening for next year, and we'll probably be talking about that. I should have it out by next Space Hangout. So we will be talking about everything that's in the coming year that's the astronomically mandatory and bizarre, because there's a few interesting things I've come across. And we'll talk about the eclipses and the meteor showers and the prospects for those, and the mini-moons and the supermoons and everything else that's happening. So and the comets that are almost going to hit planets. That's going to be an interesting one.
Will you tell me when
coinciding-
Mercury is going to be in retrograde?
Oh yeah. I usually I don't to laundry list, because it would be like that would make the post twice as long to just list all the because Mercury spends like 75% of its time in retrograde anyway. So
that has got to explain all the bad luck then.
I have the eye toward there's some mandatory events like the eclipses, but I also try to throw in some bizarre stuff that you'll only see on this post. So.
Dave, when will Earth be destroyed? That's what the people want to hear.
2012, you missed it.
It will be destroyed in 2015 when the new Star Wars and the new Avengers movie comes out, because the internet will implode.
The density, that's true. You can imagine so much information will be passing along on the internet that it will collapse into a black hole, and they will drop into the Earth, and they will
be immediately rocketed back to the 17th century.
Yeah. So it will be information density.
Yeah. The internet will become a neutron net, and it will be so a spoonful will just
it'll gain self-consciousness.
What's a neutron net?
Elizabeth, now you talked about the Mars mission, but you're going to be maintaining a series, right?
I'm going to be doing a series. It'll be running on space.com during that time, and during that time I'll also be trying to post updates on Twitter. The thing is, we do have limited internet, just like they do in space. We want to make it as much of a simulation of that as possible. But I will be online quite a bit, and if you guys have any questions, you're always free to tweet me at HowellSpace or to try and track me down through my website, and I'll be happy to answer any questions as we go. We should have some videos also that are going to be uploaded to the Mars Society YouTube, because what we're doing is we're trying to duplicate those space-to-ground videos that NASA's just been doing between the space station, talking about the space station research. So we're going to be trying to do the same thing down on our little site there.
Will you have to wait a half an hour every time you click a link on the World Wide Web?
Actually, one thing I should note is that we are not allowed to do phone calls or live chats or anything like that, because it's not an accurate simulation of what would happen. And that's why they have such an emphasis on us doing videos, because that is how the crews on Mars would likely be communicating with the people here on Earth, uploading videos and talking about what they've been doing during the day. And then they would just sit there and patiently wait until the people were able to put together another video and send it back. So likely it would just be about once a day.
I think video is good, because we can really watch the breakdown, the mental breakdown, and when the space madness sets in, and we can sort of see in stages as your personal journals turn into a sci-fi horror movie.
Okay, exactly. About week one, maybe beginning of week 2 is probably when it's going to happen to me.
Yeah.
So.
Yeah. Okay. Great. Perfect. Jason Major, what's happening?
You know what? I'm just going to put up some awesome space news as it happens in my typical knee-jerk journalistic pattern, where if I see something cool, you'll find out about it. So.
Do you promise?
I promise. I promise MiniMoon, and I promise knee-jerk journalism.
Swear on the
Knee-jerk journalism.
Knee-jerk journalism. Nicole Gugliucci. Now that you have moved to your fantastic new office, you have a super-duper computer, you've got your own TARDIS, what can we expect in the new year?
Well, actually, funny you mentioned Mercury in retrograde. I'm slowly working on a post on Skepchick about why so many people believe that Mercury being in retrograde makes your technology go weird. I'm trying to track down the origins of that. And then actually for my actual job, I am writing all the grant applications to keep CosmoQuest going for the next couple of years. And getting ready for the American Astronomical Society meeting, which is the first-ish week of January.
Where's that going to be?
It's in the D.C. area. It's at a resort in Maryland, so it's not in its usual place in D.C., so it's a little bit off the beaten path, I think. But I will be there, and I'll be judging student posters, giving a poster, and doing workshops, and hopefully doing at least one live hangout from the meeting.
Fantastic. Yeah, that'll be great. And so, of course, I am publishing Universe Today and releasing a whole bunch of cool videos on YouTube. We've upped the rate, so we're now doing 3 videos a week. We've got the 2. I'm hearing like a buzz. Where's that coming from?
Inside your head.
Inside. The bees.
It's the aliens that live at a very high rate of speed.
I think it's that Boston Dynamics robot coming to your house.
So we've got so the normal 2 videos we've been releasing every week, and we've now added a 3rd level of interviews. So once a week we've done an interview with who have we gone with so far? We've had Mark Morris, we've got Mike Brown, we've got Kevin Grazier, we've got... So anyway, these are coming out every week, for weeks and weeks, and it's
You
just
just did one with Thad Sasbo, right?
we did Dr. Thad Szabo, which was great.
Szabo.
We had Emily Loktawala the previous week, and tons more coming. So people really enjoy it, and it was great to interview them. Actually, we got so much footage. I don't even. We could be digesting this for years. So anyway, so thanks everyone to the dedicated team of space journalists. I, as always, super appreciate you joining me on this hangout. Thanks to everyone who watched us, and if I hope you have an interesting and fun holiday, whatever you plan to have. I think we're gonna have a Festivus. Yeah.
Feats of strength
for the rest of us.
and we will see you all next Friday on the 27th, where I think we're gonna try and do a wrap up. We're gonna try and sort of talk about all the big stories that happened in the year. A clip show, really. So.
Ooh.
All right.
Only
Thanks.
without clips.
Without clips,
Please
yeah.
do
All right.
not
Well,
help.
thanks everyone for watching, and we'll see you all next week.
Merry Christmas.
Happy holidays, everyone.
Bye.